All right, I think we are going to get started. So we're still missing Owen, right? Owen, Connor. It's a Connor, okay. So let me see. Oh, there he is. All right, Isaac, can you hear me?
Yes.
Okay, great. Okay, then we'll get started. All right, so classroom service disinfecting today is Luke and Noah. Okay, so and again, just a reminder, homework number 2 will be due on Tuesday. Okay, so if you haven't got started, it's time to get started. I think you should be able to finish all of the problems. Okay, I think I see some of you guys have done that already, actually. All right, another announcement, kind of, yeah, put that way. Announcement is like I'm planning to probably having exam 1 on the Friday in 2 weeks. Okay, so either that day or maybe the Monday after that. So ish. Okay, so around that time, we should cover chapter 1, 2, and 3 in the first exam. Okay. All right. So briefly, last time we talked about the dot product of two vector or scalar product. If you have two vectors, you do multiplication of the two, you can do dot product or you can do cross product. Okay, so the difference is the dot product will give you a scalar quantity as a result, and then if you are doing cross product, you will get a vector. Okay, we'll just see that today. So for dot product, A vector dot B vector, it gives you magnitude of A times magnitude of B, and then cosine of the angle between the two. Okay, so that's dot product. Now we will talk about cross product today. Okay, so if you do A vector cross B vector, okay, so writing in this form, A cross B, A vector cross B vector, and you get a new vector C. Okay, now for new vector C, because it's a vector, so it's not just the magnitude. Okay, so for dot product, it just gives you a scalar, so it's just magnitude. Okay, so in this case, for the new vector C, you need a magnitude and also a direction. Okay, so for the magnitude, it's the magnitude of A times magnitude of B, and then cosine of the angle between the two vectors. Okay, so this time you'll have you have sine. Okay, the previous when you have dot product, you have cosine. That's magnitude or the the value of it. Okay, so AB sine of the angle between the two. Now on the direction of this new new vector C, then we'll define in this way. Okay, so it's the right hand rule. Okay, or before that, it actually in the figure it shows here, if you have A cross B and then you have B cross A, so the resultant vectors, they are actually opposite of each other, or then you put a negative sign. Okay, so A cross B should be equal to minus B cross A. Okay, so you get different directions, but the magnitude is still the same. Okay, of the two is still the same. All right. Now the direction-wise, it's the called corkscrew right-hand rule. Okay, so imagining you are opening the cork of a bottle. Okay, so this is how you define it. So if you do A cross B, so then the direction of the resultant vector should be in the direction that is perpendicular to the plane of A and B. Okay, so if you have an A and B, it forms a plane because it will be two lines and then perpendicular to it. Okay, so either perpendicular, say, let's say these two vector A and B. All right, so it'll be perpendicular to this plane, either going upward or going downward. Okay, now that has been determined by corkscrew hand rule. So if you have a corkscrew, you can turn it in the way. So if you do A cross B, then you are turning from A towards B, okay? Then the progression of this corkscrew will be the direction of the resultant vector, okay? Now, on the other hand, if you are doing B cross A, now B is in that way, so you are turning it in this way, right? So the other way around. So you can actually view it from the top here. So yeah, going that way from B to A. So then the progression of the corkscrew is going in downward direction. Okay, so this is right hand rule. Or you can just use the right hand rule. Say use your right hand, put up the three finger, the thumb, this finger, and then the middle finger. Okay, so then A cross B will give you C. Okay, so put it in this way. So the middle finger is perpendicular to the two. Okay, so then if you are doing A cross B, then we'll give you C in that way, right? So if you are doing A cross B, then it goes that way. Okay. All right. So that's why it's called right hand rule there. Okay. And again, it's anti-commutative because if you do A cross B, then it gives you negative of B cross A. Okay. All right. Yes, done with this one. Okay. Now, similar to dot product, if you do A cross B plus C, then this is distributive, okay? So you can distribute A into the parentheses. That means you'll get A cross B plus A cross C, okay? You'll get two terms and you have two vectors to add up, okay? Now, special cases, for example, if you have like this, the unit vectors of the x, y, and z directions, okay? So when you are doing A or I cross I, all right, then that should be the same as J cross J and then K cross K, that should go to 0, okay? Because remember, for the magnitude of the two vectors cross product, it's magnitude of the two times sine the angle between the two, right? If the two are identical vectors, then the angle between the two is 0. If you do sine of 0 degrees, then that's 0, okay? So then whatever, if you have two identical vectors, no matter it's unit vector or two identical vector, whatever magnitude it should be, like if you have a vector cross itself, it will give you 0, okay? So two identical vectors, if you do cross product, will give you 0. Or think about this way, even you have two not identical vectors, but they are pointing in the same direction. Say one is 1 meter in the I direction, one is 2 meter in the I direction. As long as they are in the same direction, then the angle is 0, right? So then it will give you 0, okay? If you do the cross product of the two. All right. But other than that, if you are doing cross product of the two vectors that is not in the same direction, then in this case, if we are looking for the ijk direction, which they are perpendicular to each other, okay? So in this case, you can see if I are doing I cross j, then it will give you k, right? Use your right hand rule. So put up I along the direction of the thumb, j in this finger, and then k will be in direction of the middle finger, right? So I, j, k, okay? So that's all also how you usually want to set up your x, y, and z coordinate system, right? X, y, and z in that way, all right? So then it goes with this rule here. If you do I cross j, it gives you k. If you do j cross k, it will give you I, okay? Again, you put thumb in the direction of the j, k in that direction, then this middle finger is in this direction of the I, right? So you can see that I cross j will give you k, okay? And then k cross I will give you j, all right? In that way. However, if you are doing the other way around, if you are doing, say, I think the last one here, I cross j cross I, all right? So then you are in the clockwise direction here, j cross I will give you a k, but negative k. Okay, it's going to be in the negative direction. All right. And then if you are doing I cross k, it will give you negative j. Okay, because the cross product, they are anti-commutative. Okay. If you change the order, it will give you a vector that's the same in magnitude but opposite in direction. Okay. All right. Now, in general, if you have two vectors, A and B, they are expressed in the components, okay? So because the cross, this is the multiplication. If you have two, like one parenthesis with several terms across another parenthesis also have several terms in it, then it's distributive, okay? So meaning you are distributing this guy into this one, okay, and then this guy into the parentheses, the terms in the parentheses, and then the third one into the parentheses, okay. So similar to what we did last time, you'll then get 9 turns, okay, because 3 by 3 will give you 9 turns. So then you have first turn here, second turn, third turn, etc., until you have all of the 9 turns written. Now, not all of them will be or actually some of them will be 0, just like last time, okay, but less turns will be 0 in this case. You only have 3 turns that is 0. The ones has identical vectors cross each other will give you 0. So I cross I will be 0, j cross j will be 0, k cross k will be 0, okay. On this one, I cross j will give you k, so ax by times k in that direction, okay? And then this one, I cross k will give you minus j, okay? Because k cross I will be positive j, then if you reverse the two, will be giving a negative j, okay? In that case. Also, this one, j cross I will be negative k, j cross k will be positive I, k cross I will be positive j, k cross j will be negative I, okay? So yeah, that's what you get here. So some of the terms are 0, and then the rest are not. Okay, the rest are either an ij case or minus ij, minus I, minus j, minus case. Okay, in those directions. But you can combine the ones with I and the minus I. Okay, so put ayBz minus azby in the first one for the x component of the new vector, and then what for the y component of the new vector will be az bx minus ax bz, okay? And then for k will be ax by minus ay bxk, okay? All right. So if you can memorize this, it's great, okay? But there's some trick here. So for example, if you are looking for x component of the resultant, okay, then it should be equal to here, there should be nothing associated with the x component of the original vectors, okay? You wouldn't have ax or bx there, okay? Then you should have like ay bz minus az by, okay, in that case, all right? You take the y component from one and then times the z component from the other minus the z component from the one and then times the y component of the other, okay? Similarly here for the y component, it will not contain any ay or by, okay? But you'll have azbx minus axbz, okay? For the z component, it will not contain any original z components from the two, okay? So axby minus aybx. All right. Yeah, this is a little bit trickier than the one we had before, but you can always refer to this, okay? All right. Now let's have some exercise here. So the first one here says find the cross product A cross B for the two vectors, okay? The two vectors being 2.0 in I plus 3.0 in J plus 4.0 in K, and then B vector is 3.0 I, 4.0J minus phi 0K, okay? And then the second one is A equal to 3.0I plus 4.0J, B minus 3.0I 4.0J, okay? Go ahead and then try those two. Then we can look at this solution together, okay? You can submit your answers by clicking on this PowerPoint slides. Just so you guys know that every time if we have a Zoom lecture, it will be recorded, okay? So everything you put on the chat text, it will be recorded, okay, as well. This is for the reason that if someone is having is online and they might have internet issue, he or she can always go back to check the videos, okay? So I'll post the videos online later, okay? And I'll probably do the Tuesday's lecture. I will also post it online, okay? Oops. Okay, so I will get started in about 30 seconds or so, okay? All right. You guys can keep submitting your responses, but we'll get started. So a quick look on your submissions here. I see quite a few guys actually got the both part right. Okay, so let's take a look here. So I'm gonna to just show my camera here. Okay, and then full screen here. All right. So you can use the expressions we derived earlier. So this is A cross B vector product. Okay, so we know that Cx is going to be AYBZ minus AZBY, and then Cy is AZBX minus AXBZ. CZ is AXBY minus AYBX, right? We have the three components. So we will simply just plug in the numbers, okay? So we have a lot of things to plug in here. So sometimes we may get tangled up along the way. So I think that's why some of you guys didn't get it right, just because you are plugging it wrong, okay? Because there's too many stuff to do all at once. All right. So then we'll look at the x component. It should be AY, BZ. AY is 3, BZ is minus 5, okay? You can refer to your PowerPoint slide. So then this is 3 minus 5 minus AZ is 4, and then BY is also 4, okay? So I think I direction plus AZ is 4, and then bx is 3 minus ax is 2, bz is minus 5, okay? This is j, and then plus the z direction ax 2, by 4, and then ay 3, bx also 3, okay? It's k, okay? So then minus 15 minus 16, that will give you minus 31, okay? And 12, 3 by 4, 12, minus negative, okay? So it's plus 10, so 22, okay? 8 minus 9 will give you minus 1, okay? So minus 1 if you want to write, or just minus k, okay? So this is part A, all right? Just a little bit tedious, okay? But straightforward. Now B sounds a little bit tricky. You are given that just in two components, right, for the two vectors, I and j. So then that means in this case, your az is 0, your bz is 0, right? The y component, the z components are zeros for the two vectors, all right? So you can do the same here. A cross b refer to the same expression here. You do ay bz minus az by, okay? So in this case, ay is 3, and then bz is 0, minus az is 0, 4.0, okay? That's I direction, plus, now az is 0, minus 3, okay? Minus ax is 3, BZ 0, okay, J, and then plus the K direction 3.0, 4.0, minus 4.0, minus 3.0, okay, in K direction. So you'll figure out that now this will be 0 minus 0, okay, 0, so 0 minus 0, 0, okay, gets you 0. So the only thing remaining will be this guy, okay, so 12 minus 4 times negative, okay, so 12 plus 12 will be 24K, okay. All right, so that's what you should have, okay. Any questions you guys might have? All right. So yeah, I was looking for another way of doing vector cross product online. So let's this video, or actually you can look it up. You can do it if you have learned matrix, you can do the determinant of the matrix. Okay, so A cross B. So basically, if this is A cross B, all right, then the resultant will be determined of you first put in the first row you put ijk in vector form, and then the x component, y component, z component of the first vector in the second row, x, y, z component for the second vector in the second row. Okay, so the result will be the determinant of this 3 by 3 matrix if you have learn matrix. Okay, but if not, then it's fine, you can just do what we do in the class. Okay, so to do this matrix notation, then so you can write down this way. Okay, so if you have a vector this wire, okay, it should be ax, right, in I direction plus ay in j direction plus az in k direction, right? And then if you have general in another vector bx plus by in j plus bz in k direction, right? So to do the determinant of the 3 by 3 matrix, I'll do A cross B vector. Then, so the two lines, that means we are doing determinant of the matrix. Okay, so you set up the matrix as ijk. On the first row, the second row, you'll have ax, ay, az. Second row, you have bx, by, bz. Okay. There's one way to do this matrix is you copy these two rows over here next to this one. Okay, so I and J, copy them over, AX, AY, BX, BY, right? Just copy the two rows over. Oh, actually, this guy goes here, this guy goes there, okay? Then next thing you want to do is this way. So multiply those three, okay? And then multiply those three terms and then those three terms. I didn't put them in that direction. All right. And then for the K here, you go in that direction. Some of you guys might have learned this already. Okay. So then whatever the arrow goes down, they are positive terms, and then goes up, they are negative terms. Okay. So for the first one, you will have I times AY BZ, right? And then plus J times AZ BX, and then plus K times, that goes here, AX BY, AX BY. All right. Now for these three arrows, these three terms, it will be negative. So negative of, let's see, we'll take a K, we'll put the K, the one has K over here. Okay, so it'll be negative of K. Now you can do bxay, right? bxay. For the I terms, it will be this multiplied by that and then multiplied by I. So minus I byaz, okay? And then the j term be minus j bzax, okay? So you'll end up with the same as what we had, okay? So basically you combine these two, right? To get you the I component will be aybz minus byaz or azby, okay? So it'll be your I component plus the j component azbx minus bzax j component, right? Plus the k component axby bxay k component, okay? So if you do this way, you just need to know how this is being done. Then you don't have to memorize the these three. So this will be the same as these guys, right? The ones we had earlier, okay? So you can compare them. Let's see. Let's see here. So azby minus byaz, right? azby minus byaz. These two are switched, but the same. And then for the y component is azbx minus bzax, okay? And then the same for the k component, okay? So this is the using the determinant of the matrix. You can do it that way, okay? All right. Yeah, and then yeah, I think this video talks about that, okay? So let me see if I can play this one. I need to share my screen. Share computer sound.
Dave here. Let's find cross products.
He knows a lot of all kinds of stuff. Professor Dave explains.
Earlier in the series, we learned about vectors and their operations, including one way to multiply two vectors together, which we called the dot product. But the dot product is just a scalar. There is another way to multiply two vectors to get another vector, and this new vector is called the cross product, which is denoted by the multiplication sign. Now that we know a little bit about matrices and their operations, we are ready to understand how to find the cross product of two vectors. So let's learn how to do that now. Let's take two vectors, A and B. A has components 1, 3, 4, which can also be expressed as I plus 3j plus 4k. And B has components 2, 7, negative 5, which can be expressed as 2i plus 7j minus 5k. The way we find this cross product, or A cross B, is by finding the determinant of the following 3 by 3 matrix, with I, j, and k across the top row, the components from vector A in the second row, and the components from vector B in the third row. We know how to get the determinant of a 3 by 3 matrix, so this is no problem. We just get I times the determinant of this 2 by 2 matrix, minus j times the determinant of this one, plus k times the determinant of this one. Now we can find each of these
We'll do another exercise here. Okay, so on this one here, um, so as the figures show here, these are all two-dimensional vectors in the xy plane. Okay, just to be clear, this is xy plane. These are two-dimensional vectors. Now, remember, if you do two-dimensional the two vectors in xy plane, if you do a cross product, it will give you a vector. Okay, then that vector should be in a direction perpendicular to that plane, x and y plane. Okay, so the resultant, if you have two vectors cross product, say this one and that one, it should be a vector in the k direction, either in the positive k or negative k. Okay, because the resultant from the two cross product will be perpendicular to the plane those two make. Okay, now that product will give you a scalar. I'm not sure if Isaac, can you still hear me? Because I think I switched a little bit. Can you still hear me? Can you give me a confirmation?
Yes, I can hear you.
Okay, great, thanks. All right, so yeah, so for A, you have A cross F will give you a new vector, and then D cross B will give you a second vector. But when you do the two dot, then the final result should be just a scalar. Okay, and then for B, A dot F will give you a scalar, C cross B will be a vector. So scalar times a vector, the result should be a vector. Okay. Yes. Yeah, because the first parenthesis is scalar. In second parenthesis, will give you a vector. Right. So resultant will be a vector. Yeah. Ooh. Okay. Um. So I think we'll take a look here together now. Um. So on the first one, you're doing So let's take the first parenthesis here. So A cross F, right? So you have A here, and this is F, all right? So you kind of see A is making an angle of 30 degrees with the horizontal line in that direction, but B is also making, or F is making a 30-degree angle, but in the opposite direction. So these two are in opposite direction if you move this guy over here, right? So they are in opposite direction. Now if you do A cross F, that means you take magnitude of A times magnitude of F, right? And then times sine, right? Sine of the angle between the two. So if they are opposite to each other, that means the angle is 180 degree, okay? If they are in the same direction, is 0 degree, opposite is 180 degree. But sine of 180 degree will give you a 0, right? Sine 0 or sine 180 degree is 0. So that will tell you the first one will give you a 0 vector, right? 0. Now 0 times whatever the second one, we don't have to actually figure out the second one. It's a vector, 0 times whatever, it should give you a 0, okay? So on the first one, the result should be 0, just 0, okay? Yep. And then on the second one here, now we can look at the first parenthesis here. So this will give you it's a dot product. It will give you a scalar, right? So A dot F, that means the magnitude of A times magnitude of F, and then cosine of the angle the two makes, okay? Now the two is opposite to each other, so angle be 180, cosine 180 is minus 1, okay? Cosine 0 is 1, cosine of 180 is minus 1. So we minus 10 multiplied by 20, so minus 200 from the scalar here, okay? Now on the vector part here, C cross B, so you'll be looking at C here, and then B here. You can move this guy parallelly over, okay? So B will be pointing in that direction. So C cross B, all right? So you can use your right-hand rule here to determine the direction of your resultant vector of C cross B. So C cross B, then C in the direction of the thumb, B in the second finger here. So the middle finger will point to the direction of the resultant, okay? So C cross B looks like will give you a vector in the positive z direction, okay? If this is x, this is y, then positive z is in this direction, right? That's also by the right hand rule. So x, y, z, okay? All right. For the magnitude, so the direction should be k, okay, or positive z. Then the magnitude should be c, magnitude of c, which is 12, times the magnitude of b, which is 5, okay? 12 times 5 gives you 60, and then times sine of the angle between the two, okay? Or actually cosine. No, sine, sorry. So sine of the angle between the two. So then sine, the angle between these two, C and B, should be 60 plus this 53, okay? Sine of that 113 degrees, okay? So you'll be doing minus 200 from these two guys times 60 times sine of 113, okay? The result will be 11,046, okay? So yeah, I think the first response here, that's right, okay? But you need to specify k direction here, okay? This should be, you should indicate this is in k direction, 11046 is k, okay? Because it's a vector, there should be a vector, okay? Any questions from you guys? All right, If you are good, then we'll stop here. Okay, I'll see you guys on Monday.